everyone, welcome to the Bits and Pieces channel, a tutorial on absolute value. So what is absolute value? See, absolute value is, let's write it as the absolute value of x, is when you take a number and you find the positive version. So for example, the absolute value of 5 is equal to 5, and the absolute value of negative 5 is also equal to 5. What it essentially does is that if you have a positive, it remains the same. If you have a negative, it becomes the positive value. So let's see how we can apply this to algebra. And how could that even work? If we were given this equation right here, 6x plus 9 equal to 21, we would think that there could be only one solution, right? So we solve it and we get 6x is equal to 12, and then x is equal to 2, correct? But something seems a little bit off, because when there's an absolute value, that means that whatever was in these bars, right, whatever was the equation right here, that could have either been positive or negative, right? Because every time you put something into absolute value, it always comes out as a positive. So we need to think of this in a different way. And how we can do this is by separating these equations, right? So we can separate right here. So in one instance, 6x plus 9 is equal to 21. That's like the normal instance, or if we assume everything is positive. And we solved it before, it's x equals to 2. And now I'm going to pause for 2 seconds and let you guys solve it. And let's see what the other solution could be. Okay, so let's get back to it. So this time, the easiest way to do it is that we have to think of it like there is a new negative solution, right? If this could be any number, 6x could be any number, and we don't know if it's a positive or if it's a negative. So the easiest way to find out what both the solutions are is that we could do 6x plus 9 is equal to negative 21. And that's how we can find out what the new answer is. So once we plug that in, we get 6x equal to negative 30. And let's keep on going. Divide by 6, x is equal to negative 5. So the final solution is that x is equal to either 2 or negative 5. And the way you express these solutions is you use curly brackets. It completely depends. People could use other things too. So let's try to plug this in. If we multiply 2 by 6, that's 12. 12 plus 9 is 21. And we take the absolute value of that, that's still 21. And then let's look at this from a perspective of negative 5. So negative 5 times 6 is negative 30, plus 9 is negative 21. But when we put that through the absolute value, it's going to come out as a positive. So this solution works out. So that's the easiest way you solve absolute value in absolute values. But now let's think about it if what was outside the absolute value was actually a negative. So is this even possible now? If you plug in any number, let's say from negative infinity to infinity, you can't get any number that when you make it positive, it can equal negative 21, right? Even if you take negative 5, you still get this value right here, right? Negative 21 absolute value is equal to negative 21. But is that correct? No, it's not. Because when we take the absolute value, that means that 21 is equal to negative 21. And that can't be true. So the only solution to this equation is that there is no solution. That's called a null set. It's a special case. And let's look at 2 more examples. So let's say there is a number outside the absolute value. For example, let's say there was a 3 right here. And let's say this was actually not a negative, just a regular 21 that we had before. Uh-oh, it's not going to work. Sorry about sides. But let's assume it's 21, right? So what do we do if there's a coefficient out there? Simple. We just divide both sides by 3. Think of it like solving in like any equation. Whatever you do to one side has to equal to whatever you do to the other side. That's it. You just solve the equation, but you gotta remember to look out for the absolute value bars. Now let's go into the more difficult aspect of this, and that's absolute value inequalities. Now, absolute value inequalities are a little bit complicated. And I think the easiest way to show them are right here, absolute value inequalities. So if we just search them up, we're gonna pull up a image and we'll go over like how that image works. So when you get an absolute value inequality of this, you need to know the basics, right? So what are the basics? What do we know about absolute value? We know that x, the absolute value of x could equal both 5 and negative 5, right? Because x could be negative 5 and that will still equal 5. And x could equal 5 and that will still equal 5, right? And the way inequalities work is that there's open circle and then there's closed circle. And the way that works is very simple. Open circle is when it's not greater than or equal to. So that would be like this or this, right? It would be either this or this. That's when you have an open circle. When you have a closed circle, it's when it's greater than equal to, less than equal to. That's the way inequalities work. So with absolute value, it's the exact same thing. For 5, you can go either this way or you can go either this way. That's all you need to know. Or is it? Because absolute value inequalities get a lot more complicated. And that's when you talk about and or. See, inequalities, you can have these things called compound inequalities. And those work by saying that this statement, so that's like, let's say a random inequality, and or this statement. And you have to graph that on the number line. And that's what compound inequalities are. So if you don't know about them, I would recommend learning about them in the past, because absolute value inequalities are essentially a harder version of compound inequalities. So if we pull up a image of them, a compound inequality looks like this. So and is when they both come together, like so, and or is when they go in like opposite directions, like so. So that's how absolute value inequalities work. That's how compound inequalities work. So then how do absolute value inequalities work? They use a simple trick called Gore-Land. And Gore-Land is a fun acronym to remember. So you remember Gore-Land. And we can look at the letters and we can figure something out, right? So G stands for greater than or equal to. So this or this. And what does greater than? Every time you have a greater than absolute value inequality, that's going to be an or. And when you have a less than absolute value inequality, like this or this, you're going to have an and. So let's look at an example and let's put it into perspective. So I'm just going to search up examples right now so I can show you guys and we can take a look. So for example, let's take this. All these problems that they have given us, and let's solve it. So if we just move over to the right here, and we can just paste the image. So that's what we're talking about right here. So they give us x plus 7 is less than 4. So if we go back to what we learned, is less than, what is less than equal to? And. So we find out both the solutions, right? And I don't think this picture actually includes the absolute value, but let's assume they're absolute values right here. Let's only look at number 1 for this example. So let's graph it and understand how to do it. first we need to get the number line out, and you guys can label the integrals. I'm just going to show it like as a number. So x plus 7 is less than 4. And how could we do this? We could solve it using the first way, the two steps method. So we split it up, and let's go back to the equation. X plus 7 is less than 4. So one of them could be x plus 7 is actually less than 4. And the other one would be x plus 7 is greater than negative 4. Now here is it where it gets a little bit hard. See, in inequalities, the rule is that when you're multiplying or dividing, you flip the sign. So when we went here, we actually flipped the sign. We got it to 4 to negative 4. So you got to make sure to actually flip the sign too in the inequality. And that's like a common mistake area that people make mistakes on exams. So if we solve it right here, that's x is less than negative 3. And if we solve it right here, x is greater than negative 11. And if we remember, this is supposed to be an and inequality, correct? So let's go up there and graph it. So we can take the two numbers that we got, negative 3 and negative 11, and we can just put those. If you're on an assessment, I would suggest, well, that's messed up, sorry. But I would suggest actually labeling all the numbers like they do in the example above. So negative 11, and let's see, negative 3 is right here. So the first thing we got to remember is an open circle, closed circle, because it is a not like an equal to, it's just less than, that's going to be an open circle. So from negative 3 to 11, and that's how we get our solution. So of course, there is a lot of special cases in compound inequalities, but as for value inequalities, all you got to remember is that when you take a number, it's going to come out positive. And if there is no positive, then that's a null set. And any number to negative 5 is just going to be equal to 5. And the last thing I remember is score land. Thank you for watching, and I hope you subscribe.